Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mask coder this side. So in this video we are going to discuss the problem of deleting a node, right? We have already saw what is a linked list. We have already saw how to insert a node in a linked list, right? And now it is time to see how to delete a node, right? Because one limitation of the array was that whenever I was deleting some elements, it was still using the space, right? It was still using the space. But in the linked list, I can actually free that space. I can actually free that space. How? So suppose this is my head, right? This is my head. Now, as in the insertion, I have three options to delete this position or someone from the middle or someone from the end, right? Here also three operations will be occurring. I can delete from the front, from the rear end, from the middle element, right? And we will be discussing them sequentially. So let us see the front first. Let us see the front first, right? So if I want to delete this 4 node, what will happen? What will happen? My linked list would look something like 3 with 2, with 1, with 5, with 6, with 8. Now, changes are that this head is now here. That is, my head position is changed. My head is changed. Another thing is, I don't see another thing, right? I don't see another thing. So when my head changes, you can see that 4 node is actually getting deleted. The node 4 is getting deleted. The memory of old head is freed, is deleted, right? I can use it for another values also, right? So what will I do? I will say my head is initially here, right? What will I do? My new head is this. So I say I make my new head as this, right? So I will say, let me write it. So I will say my x that is equals to new head is equals to heads next. That is my x is equals to my head of next of head. My x will come here, right? After that, I can say delete this head. After that, I will say delete this head. Delete head. What will happen with this operation? This operation will actually delete the node along with this next pointer. I don't need that, right? I don't need that. Okay. Now I have my x pointed here. I will just assign head equals to x. I will just say head is equals to x, and my new head will be assigned to my x, and that is what I wanted. That is what I wanted, right? And how many operations did it take? It only takes constant time complexity, constant space complexity, right? So actually it is very good, right? Now move to the rear part. Move to the rear part. That is deleting the last node. That is deleting the tail node, right? So this is my actually tail. My tail will get shifted backwards. My tail will be here now. So after deleting this node, that is 8th node, what will my linked list look like? It will look something like 4, 3, 2, 1, 5, 6, and I have deleted 8, right? Deleted 8. So suppose my tail is here. Again, as in insert, we wanted to reach here. We wanted to reach here. Why? Because the changes here is that this next is getting changed to null and the node is getting deleted, right? Changes is next is getting changed. Firstly, it was pointing towards the old, but now it will be pointing towards null. Again, I have the reference to head. I have the reference to head. What will I do? I will make a tail is equals to head. We will be seeing the code for all this, right? I will make a tail here. Now, what will be my option? Now, I want to reach 8. I want to reach 8. I want to delete 8, right? Tail is actually this. I want to delete 8. So I will have to reach here. I will have to reach here because I have to make changes to this node next, right? This node's next. So what will I do? I will just change the tail up until, like, suppose my tail is here, then my tail will come here in the traversal, then my tail will come here, then here, then here. At here I will have to stop it. What is the condition of this tail? What is the condition? So I can say that whenever I want to find the tail, I will have to relate it with null. I will have to relate it with null, which is present right now here, which is present here. What will I say? I will keep my tail here. That is tail next, next. That is next, then next of tail. That is while tail next, next is not equals to null. This operation will land me here. This operation will land me here, and I can simply say that my node x is equals to tails next. This is my old tail. My tails next is now my old tail. I will say delete x, and my tails next is now equals to null. So I have successfully deleted the node 8. I have deleted the node tail, right? What is the time complexity? So you have to traverse approximately the whole length, that is O of n minus 2, sequentially equals to O of n only, right? So time complexity is O of n, space complexity is constant, O of 1, right? O of 1. So I guess these two operations didn't require much attention, but yes, I would like to focus you on middle part whenever I am deleting a middle node, So my linked list is 4, 3, 2, 1, 5, 6, 8. Suppose I randomly pick this value to be deleted. I want to delete this node. What are the changes? First of all, let us see what will the new linked list look like. It will be 4, 3, 2. Now because this is deleted, 2 will directly connect to 5 now. 5, 6, 8. Right? How will the linked list take place? So what are the changes? 1 is deleted, 1 is deleted. First change is this one. What is the second change? 2's next, that is 2 is the previous, right? Previous next is equals to nodes next. That is, if this is my node, this is my previous, and this is my next, right? Nodes next. So what is happening is this next, that is 2's next, you can see this connection, 2's next is now my nodes next, right? So I will implement those changes. So now I actually want to make changes to 2's next, right? I want to make changes to 2's next. So I will have to bring a node here at this position. Again, what will I do? I will keep my temp variable here, I'd say temp here. And what will I do? I will keep my traversing my temp. I will keep traversing my temp until temp's next is not equals to node. Again, I got the condition. So temp is equals to head, while temp next is not equals to my node that has to be deleted. What will I do? I will say temp equals to temp next. So my temp is here. I will check. Is temp next equals to node? No. Is temp next equal to node? No. Is temp next equal to node? Yes. So break it out. I will keep my previous here. Now the only thing is to be done is I will say x equals to temp next. Temp next. That is, I will place my x on the node and I will say temps next is equals to x next. That is making of this connection, right? Because my temp is here, my x was here, and this was my x next, right? I made this connection and I can safely delete my x now. So delete delete x. That is the only operation you have to take for to deleting an element from the middle, to delete an element from the middle, right? Now you will not be obviously given that what is the node, so you can choose according to the node's value, right? Node's value equals to 1, so keep traversing until that. The question will satisfy that needs, right? Now, what is the time complexity here? So again, traversing, right? So O of, let's say that was at position 1, so O of position only, right? O of position. That is the only thing you have to take care of, right? And I feel that it is good time to take you to the coding section in the VS Code. Again, I was not able to find any problem link where I can show you the hidden test cases of this as well, right? So I will show you the VS Code solution of it, and I will make some test cases for you, right? Let us move there. All right, so here we are. So I have just provided the code for the linked list from the array also here. You can see here, and print a linked list. We have already discussed in the lecture 2A about it. Yes, you can have obviously go and see there. Now I have made an array like this. I have made a linked list from this, and let us try to print the linked list first. Let us see what is my original linked list. What is my original linked list? You can see my original linked list is 4312568, which is exactly matching the array, right? Now I want to delete a node. I want to delete a node. So I will write the code for it. So suppose I want to delete node from the starting, right? Delete from start. Let me make a function here. Let me name it as node start delete from start, right? It will take my head only. What will I do? My first operation was to make a new node x as head next, right? After that I said delete your head, and after that I will say return your x, right? This will give me the linked list, this will give me the new linked list. You can actually see it. So if I say my new head is equals to delete from start, and I will send my head here, and now I can say see out new linked list, and and I will print error. I will print the or new linked list, right? Let us try to run this code. Let us see what will be the output. As you can see, 4 is getting deleted. 4 is getting deleted. Let me make this as endl here also, right? Right. Let us try to run it again. And you can see that new linked list is getting 4 is not there, right? 4 is getting deleted, right? Now, same for the back end operation, for the same for the rear end operation also. So head is equals to delete from end, and I will send the head again. I will send the head again. So node star delete from end. We'll be taking a node star head only. Node star head. What will I do? I will first assign a tail temp here only. I will not make the variables as temp or tail, right? And it will be pointing to head only. Now my condition was that while my next of temp is not null, temp's next of next is is not null, right? What will I do? I will just keep traversing. So temp equals to temp of next, and whenever I reach this condition, I will say my node star x is equals to temp of next. My temp of next changes to null, and I can simply delete my x, and now I can return the head. So return head, right? Let us try it for that also. Let us comment it out and let us try to run it. So if I run it, you can act. Oh, there has been some mistake. There has been a missing of semicolon. Let us try to put it and run it. I guess it will. Yes, you can see 8 is getting deleted. That was at end. 8 is getting deleted. So we have checked for the start and checked from the end, right? Now it's time for the middle. So let us delete the value 1. Let us try to delete the value 1. I will be finding my node using the value. I will say head equals to delete from mid, and I will be using the position the value as I will be sending my head also, and I will be sending 1. I want to delete the node having 1. Let us define a function here. So node star delete from mid. I will be taking my head as head here, and I will be saying int value. What will I be doing? I will make a temp variable which is pointing to head, and I will say while temps next is not equals to my value. That is, I am on the up until I am not on the previous value, right? I am not on the previous node of the deletion node. What will I say? I will say temp equals to temp next. That is, keep traversing up till there. Now I will make a node star x as temps next. This is the node I have to delete. I will change the connection, that is temp next will become x next, and I will simply delete it. Delete x, and I will simply return my head. Right? Why is this showing an error? Oh, is not equals. Oh, is temps next data? Temps next data is not equals to 12, right? I guess it should run fine, right? So let us try to run it. You can see that it will delete the node having 1. So you can see in the original linked list 1 is present, but in the new linked list 1 is not present. So I hope you were able to get all the concepts that how was actually everything working, right? And if you have any doubts, you know where to comment me, you know where to DM me. I have attached my social media handles in the description as well. So please check them out. Please give me a follow. Please connect with me on LinkedIn, right? So meet you again in the next lecture. Okay. Till then, stay safe and keep coding. Bye bye.